Pandas time series, resampling, shifting, and rolling windows. Welcome! In this lesson, you will gain hands-on practice with intermediate time series tasks in Pandas. You will use the airline passenger flights dataset to learn about resampling data to different time periods, shifting values for comparisons, calculating rolling window statistics. These are core skills for analyzing trends, smoothing, and detecting seasonality in real-world data. Running the cell now. Let us start by suppressing all warnings. This keeps our output clean and easy to follow. Import NumPy as NP. Import Pandas as PD. We set the random seed to 42 for reproducibility. Running the cell now. This initial code sets up the environment by importing necessary libraries and suppressing warnings for clarity, ensuring a smooth start to time series manipulation. Although there is no visible output here, this preparation is essential before resampling the airline passenger data to observe trends over different time periods. Keep in mind that setting a random seed ensures reproducibility in any random operations later in the lesson. Now we will set up our dataset. We import Seaborne. We load the flights dataset containing monthly air travel totals. We print its shape so we know how many rows and columns we have. We preview the first few rows to get a sense of the data. Running the cell now. This output shows the initial shape and preview of the flights dataset, consisting of 144 rows and 3 columns: year, month, and passengers. Notice the dataset records monthly passenger counts over multiple years, setting the stage for time series resampling by providing a clear, structured temporal index and a numeric value to aggregate or transform. What does our data look like? Each row is a month and year with a count of airline passengers. Year, the year. Month, the month name. Passengers, total airline passengers that month. For time series work, we need a Pandas datetime index. Running the cell now. Let us build a datetime column by joining year and month, and set it as the index. We combine a year and a month as strings, add a day, and use Pandas to create a datetime. We set this as the data frame index. Pandas can now recognize the time order easily. We print the first 3 rows to see our changes. Running the cell now. This output shows the first 3 rows of the dataset after combining the year and month to columns into a new datetime index called a date. Notice that the index is now a proper timestamp representing the first day of each month, which allows for easier time series analysis. This step is crucial for organizing the data chronologically and enabling time-based operations. Next, let us visualize the monthly airline passengers. We import matplotlib to plot our data. We plot the passengers column over time. The y-axis shows the number of passengers. The x-axis shows the date. We display our line chart to see trends and seasonality. Running the cell now. This plot shows the monthly number of airline passengers over time, highlighting clear seasonal patterns and overall growth. Notice how the counts rise and fall in regular cycles, reflecting monthly trends, which helps us understand the data's temporal structure. This visualization confirms the time-based nature of our dataset, setting the stage for time series analysis. What is resampling? Resampling means changing the frequency of your data. Downsampling, going from higher to lower frequency, like monthly to yearly. Upsampling, going from lower to higher frequency, like monthly to daily. You can use resampling to spot yearly or quarterly trends. Running the cell now. Let us downsample to a yearly view, adding up passengers for each year. We use Pandas resample with Y for year, and sum up all months. We print the first few results to see yearly totals. Running the cell now. This output shows the total number of passengers resampled from monthly to yearly frequency by summing each year's monthly data. Notice the index now represents the year-end date, and the values reflect annual passenger totals, demonstrating downsampling and aggregation in practice. This highlights how resampling can simplify data by reducing its frequency while preserving key trends. Let us visualize the downsampled annual totals using a bar chart. This chart shows how many passengers traveled each year. The y-axis represents the total passengers for the year. The x-axis lists each year at the end of December. We use tight layout for a neat fit. This helps compare years at a glance. Running the cell now. This bar chart shows the total number of passengers for each year, illustrating the result of downsampling monthly data to an annual frequency. Notice how the values are aggregated, giving a clear overview of yearly trends rather than monthly fluctuations. This helps highlight how resampling simplifies data to analyze broader patterns over time. Now let us upsample. We turn monthly data into daily, so every day gets a value. We use resample with a det for day and forward fill to copy values forward. We print the first 10 days. Notice, values stay constant until the next month. Running the cell now. This output shows the result of upsampling monthly passenger data to daily frequency using forward fill. Notice how each day within January 1949 carries the same passenger count of 112, as the original monthly value is propagated forward to fill the newly created daily rows. This demonstrates how upsampling preserves data continuity by filling in missing intermediate values. Try changing fill to bfill and see how the values change. Shifting data, comparing to the past or future. Shifting means moving values forward or backward in time. This helps us compute things like month-over-month or year-over-year changes. Running the cell now. Let us add a new column for last month's passengers. We use shift by one row to get the previous value. We print the current and previous month side by side for the first 5 months. Running the cell now. Here, the previous _month column shifts passenger counts down by one row, aligning each month's data with the prior month's value. Notice the first month's previous value is nan since there's no earlier data, and all other months show last month's passengers. This setup is crucial for calculating changes over time, like growth from one month to the next. Now let us compute the percent change compared to the previous month. We use Pandas PCT_change for percent difference, then multiply by 100 for percentage. We print both columns to see how growth rates change month to month. Running the cell now. Here we see the original passenger counts alongside the percent change from the previous month, calculated using shifting. Notice the first %_ is nan because there's no prior month to compare to, and subsequent values show increases or decreases, highlighting month-over-month trends. This demonstrates how shifting helps us create meaningful comparisons over time. Let us plot the percent changes as a line plot. The chart shows growth or drop compared to the previous month. The y-axis is percent change, and the zero line helps spot increases or decreases. The x-axis shows dates. The dashed line shows when there is no change. This makes it easy to see volatility or stable growth. Running the cell now. This plot shows the percent change in values from one month to the next, centered around the horizontal line at 0 for easy comparison. Notice how fluctuations above and below 0 indicate increases or decreases compared to the previous month, demonstrating the practical use of shifting data to analyze trends over time. This visual helps us quickly identify periods of growth or decline, reinforcing the lesson on comparing data points across time steps. Rolling windows, moving averages and more. A rolling window looks at a set of recent periods, like 3 months, to summarize local trends. Commonly, rolling windows compute averages to smooth noisy data. Running the cell now. Let us create a rolling mean over 12 months. We use rolling with a window size of 12, so every value is the average of the last year. We print the last year and earlier to see how these rolling averages look. Running the cell now. Here, the rolling 12-month average smooths the passenger data by averaging each month with the previous 11 months, reducing short-term fluctuations. Notice how the rolling mean lags the raw passenger counts and shows a gradual upward trend, highlighting the overall increase in passengers over the year. This demonstrates how rolling windows help reveal broader trends in noisy time series data. Try changing window equals 12 to window equals 6 and watch how the rolling mean gets more responsive. Now let us compare the raw passenger numbers with the rolling average. We plot both lines on the same chart. The original data will look jagged and jumpy. The 12-month average line looks smoother and helps us spot long-term trends. A legend shows what each line means. We add a clear title. The y-axis is number of passengers. The x-axis is the date. This helps us see how rolling means reduce noise. Running the cell now. This plot compares the original monthly passenger counts with their 12-month rolling average, smoothing out short-term fluctuations to reveal longer-term trends. Notice how the rolling mean line is smoother and lags slightly behind the raw data, demonstrating how a rolling window summarizes recent values to highlight overall patterns. This helps us better understand seasonal effects and general growth over time. This comment explains that we're computing the rolling standard deviation to observe month-to-month variability. We calculate a new column rolling_STD_6 which holds the rolling standard deviation of passengers over a 6-month window. We print the last 8 rows of the original passengers and the rolling standard deviation to see recent variability trends. Running the cell now. Here, the rolling standard deviation over a 6-month window captures how much passenger counts fluctuate locally. Notice how the variability increases towards the end of the year, reflecting larger month-to-month changes. This helps highlight periods of greater instability beyond just looking at raw passenger numbers. We create a new column that shows the month-over-month change in the rolling average. We use the difference function to calculate the difference between each rolling average and the one before it. We print the last few rows of the rolling average and its monthly change to see recent trends. Running the cell now. This output shows the 12-month rolling average of the data alongside its month-over-month change, calculated by differencing the rolling averages. Notice that the rolling averages, around 460 to 476, smooth out fluctuations, while the rolling_mean_difference column reveals the local trend in these averages, highlighting incremental increases each month. This confirms how combining rolling windows with differencing helps track gradual shifts over time. Can you use difference on other rolling statistics? Try it out after the lesson. Mini project, highlighting key periods with rolling averages. Let us combine what we have learned. We will find the 6-month period that had the largest average number of passengers. Running the cell now. We calculate a new rolling mean over 6 months. We locate the date where this average was highest. We find the 6 months that make up this peak period. We print both the passenger count and rolling average for those key points. This helps us spot booming travel seasons. Running the cell now. Here, the code calculates the 6-month rolling average of passengers, revealing a clear upward trend in this period. Notice the rolling mean peaks in September 1960, indicating this 6-month span had the highest average passenger count. This highlights how rolling averages help us identify key periods of maximum activity in time series data. Recap: resampling, shifting, and rolling windows in Pandas. Resampling adjusts how often we measure our data. Shifting lets us compare values across time. Rolling windows help us smooth, spot trends, and measure volatility. With these tools, you can handle many real-life time series questions. Running the cell now. Thank you for learning with us. Try applying rolling and shifting operations to your own datasets. If you learned something new, please like and subscribe for more Pandas tutorials on our channel. Running the cell now.